Hey guys, I'm going to teach you all about surface area with an intro to nets. By the end of this lesson, you'll be able to identify parts of a 3D figure and kind of unfold them to create nets. So go ahead and take out your binder, turn to the math section, and get ready to take some notes. So we're going to be talking about 3D figures. 3D means three-dimensional. That means you can see two-dimensional shapes like rectangles, but there's some depth to it, which in math means that there's a length, a width, and a height. So on the Pop-Tart box, the length would be like this right here. The height would be like this right here, how tall it is, and then the width is this right here, is what makes it 3D, is this extra measurement. So in our conversation today, we're going to be talking about surface area, and surface area is just all of the areas of this Pop-Tart box added up. So it's the front, it's the back, it's the sides, it's the tops. It's basically like if we were going to give this Pop-Tart box as a gift, and we only wanted to use exactly how much wrapping paper we needed to wrap up the Pop-Tart box. That's what surface area is. In today's lesson, it's all about nets. This is an example of a net. It's basically we took the Pop-Tart box and we unfolded it. We cut the top, we have the bottom, we have the back, we have the front, we have the side and the side. So it's like we made it flat. That's what a net is going to be. So as we start looking at an intro to nets, let's get some of these basic definitions down. There's four big words you're going to need to know about these 3D shapes. The first word is face. Faces of three-dimensional figures are any of the surfaces, including the bases. Let me show you that with the Pop-Tart box. The faces of this Pop-Tart box are going to be this front part here, the side nutritional facts part, and then the top as well. So if these all count, so will their opposites. So like the bottom part, the side part you can't see, and the back part. Basically everything you can see here. This is a face, 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 and face. Those are all faces. The next word you need to know is base. The base of a three-dimensional figure names the shape. And in a prism, it has two bases. Those are going to be parallel to each other, and they do not touch. So for example, the Pop-Tart box here is sitting on two rectangles. I could turn it and it's be sitting on a rectangle. They're all running parallel to each other. That's why this prism is called a rectangular prism. So this is an example of a rectangular prism with rectangle bases. Some shapes are a little bit different. You'll see like in this little pyramid down here, the base is a square, and you'll see other shapes like these where the base here is actually going to be a rectangle, a square, and so on. So for me, the easiest way to think about base is just what's it sitting on. The next word we need to know is vertex, and we should already know that from our discussion about angles. Just like in an angle, the vertex is the corner point of a three-dimensional figure. So in an angle, the vertex was this point. But in these 3D shapes, it's going to be the same thing. It's going to be the corners. As you can see, it makes a right angle here if you look at just that measurement with that point. But really, any corner of a 3D shape is called the vertex. So these are all vertices. Vertices is the plural of vertex. So if there's more than one vertex, you would refer to them as vertices. One thing I find really helpful about finding out how many vertices a figure has is drawings like this. You can see here that it's like the same shape as the Pop-Tart box, but obviously this is a solid figure and we can't see through it. In this picture, the dotted line is like what we can see through. It's like the back that we can't see, but we can see because it's a dotted line. So if you look in this picture, you can count that there are 8 vertices in a rectangular prism. And that little point right there, we can't see, but it would go about here in this Pop-Tart box. All right, so last vocab word that we're going to talk about today is called edge. The edge is the line segment that joins two faces. So in the Pop-Tart box, it's like where the corners meet. This is the edge. So there's an edge here as well, and here. So anything that connects the two vertices, anything that makes two faces connect, those are the edges. Take a second, and I would use this picture and see if you can count how many edges a rectangular prism has. Pause the video now and press play when you're ready to check. All right, so you can look at this and see that there are 12. There's 4 on top. You got these 2 on the side, make 6, 7, 8, and then 9, 10, 11, 12. So there are 12 edges and 8 vertices on a rectangular prism. We can see there are 6 faces because when we unfold it into a net, we see there's a front and a back, a top and a bottom, and then 2 sides. So those vocab words that we just learned are going to be really important in giving us information about these 3D figures, and that's going to relate to surface area and volume. So take a second and use what you know about face, base, vertex, and edge definitions, and let's look at these 2 shapes here. These are 3D shapes, and I want you to label the various parts of these rectangular prisms and rectangular pyramids, and pay attention to the differences between them, especially the faces. So take a second, pause the video now, and then press play whenever you're ready to check. So let's start one at a time. Let's start with the pyramid here. It's a rectangular pyramid because the base is a rectangle, or in this case, I think it looks like a square. So it's got four triangular faces. You can see that four triangles meet to the point, and it's sitting on one square base. So it's got five faces in total, even though they're different shapes. It's got one rectangular base, like I said, and it's got five vertices. You can see that here. One thing you might notice when you look at these 3D shapes is that if you kind of like look at it a certain way, then try to look at it a different way, you can kind of like invert it so that this point, especially this corner point, is pointing out and you're looking at the bottom, like you're looking up at the shape. Then if you like adjust your vision, it looks like you're looking down on the shape and it looks like you are from a top angle. See if you can do that for a second. That's really cool if you can. Looking at this in different ways is just something that might happen. And it's a helpful way to look at it to kind of adjust your eyes and look at it both ways if you can. And then the last thing we want to talk about is edges. So it's got 8 edges, 4 edges that make the triangles connect, and it has 4 edges that make the bases connect. And then obviously, as you can tell, that's different than the rectangular prism, which we went over with the Pop-Tart example. There's 6 faces, you have rectangular bases, you have 8 vertices, and 12 edges. Just be sure that you're not counting things twice. That's one mistake a lot of people will make, is that they'll count edges multiple times. But once you've drawn it on it, that's my strategy. You just don't want to draw over it again. So don't try to do it in your head. Actually draw on the shape. That way you don't accidentally count this top edge 2 times because you might accidentally count it as part of the rectangle on top. So let's actually get into the net part of this now. Nets are actually really useful. And like I said, nets is going to be like this thing right here. It's basically like we took the Pop-Tart box and cut it apart. When you do that, it kind of makes a 2-dimensional compound figure or composite figure, which is just a shape that's made up of other shapes. So if you look here, whenever we lay it out, we have this is a Pop-Tart box, and we've made it 2-dimensional, basically. And it's made up of all these rectangles of different lengths and width. That's what the L and the W stand for. When you take a net and you fold it back up, it creates a 3-dimensional object. So all solid figures have specific nets. And we see this a few different ways, and this might be a little confusing for you if you can't visualize this. So please try with me just to put yourself in this headspace and be patient with me as I explain this to you. It's kind of hard because you have to visualize this. So I'll go ahead and I'm not going to have you look at this by yourself. I'm just going to explain it to you. When you have these different nets here, the question is, determine which of the following shapes would create the cube. So you've got to kind of imagine, like one is one. This is one of them. But you got to kind of imagine like folding this up, like folding that up, folding this to the side, folding that to the side. And then if you took this and you folded on top of each other, this would be the side and this would be the top. You got to kind of imagine this shape folding together. And actually, 2, 3, and 4 will all fold together to make this cube. Take a second, pause the video, and just see if you can try to imagine 2, 3, and 4, the ways that it would have to fold together to make this cube. Okay, so hopefully you looked at that and you were able to kind of visualize in your head how this happens. 5 would not work. And if you visualize 5 folding together, it's got 2 sides that would cover the same side or face of the cube. So 5 doesn't work, but these are all nets for cubes. And they are different, but when you unfold 1 through 4 here, you make 6 squares. So these squares are the faces of this cube here. Now, turning a 3D figure into a net is actually really helpful, because if I asked you to find the amount of wrapping paper that I would need to cover exactly the faces of these 3 3D shapes, that'd be a little difficult for you. You might have a hard time thinking of that in your head. But if you use a net, you could see that actually you just need to find the area of a rectangle multiplied by 4 and a square for this example. That will give you the total area of this 3D shape. That's what surface area is. It's just the total area. So same thing for this rectangular prism. It might be intimidating if you look at this and I said find the area of all the sides and add them up. But if you look at it as a compound figure, really you're just finding the area of a square, and then you know that's the same one, and then you have the area of this rectangle. Then you do it times 4. So that's how you do surface area. And using a net is actually really useful to that. So take a second and analyze these nets, and I want to know, how is the net of the pyramid different from that of these prisms? Pause the video and press play when you're ready to check. So the way that they're different is that the pyramid has triangular faces and only one base, while the prisms both have 2 bases. And I lied to you earlier when I told you that this has rectangular bases. I was going too fast. Using that definition of just what it's sitting on, it doesn't always work, because this shape could also sit on the triangles. It's kind of a shortcut to use that definition of base as kind of what it's sitting on, but you really want to pay attention to the two sides that are parallel to each other and don't touch. And it's also what names the shape. So this is a triangular prism. It's not a rectangular prism, this is a rectangular prism. This is a triangular prism. So that's what names it. That's why these two are the bases, because those are opposite each other. So that's just a mistake I made earlier I wanted to correct. This is really what you should notice about the net of the pyramid from that of these two prisms. This is triangular faces and only one base, and these two have two bases and rectangular faces. So here in this example, you have 5 three-dimensional figures. And what you should do now is to use the measurements from the nets to label the solid figures. So I'll do the first one for you. This is a cube. And so I can see that this is the net of a cube based on how if I folded it back up, I can see that it's got 6 square faces. So this is a cube, and it has measurements of 7. So I know that this is 7. I know that this is 7. And since it's a cube, this is also 7. So it's a 7 by 7 by 7 cube. And just like we did with regular area and regular shapes, like two-dimensional shapes, I want to put the dimensions in feet. So that's the units that it was listed in. So that's what I want to keep it as. Take a second, see if you can find the net that matches with this triangular prism, and then press play when you're ready to check. All right, so I can see that this is the net for the triangular prism. It has 2 triangular bases, and it has 3 rectangular faces. So now you want to go ahead and take a second and use the measurements from this net and put them on this triangular prism. Here's a hint. For the height, you can see here is a dotted line. You're going to want to put a dotted line here on this triangular base. So pause the video now and then press play when you're ready to check. All right, so here you can see the measurements from this triangular prism. I took from this net. I took the 15 from this right here. But again, you can see that if that's 15, this is 15, and so is this, and so is this. So that's how I got a length, width, and height of 6, 15, and 5 feet. Take a second, try the next one all by yourself, find the net, and then transcribe those measurements onto this 3D figure. Pause the video now and press play when you're ready to check. So this is a 6 by 6 base. I got that from this right here, these blue lines. There's 7 feet is the like slanty length of that triangle. And then the height of the triangle is 5 feet. And I got that from here, that dotted line. So I drew the dotted line onto the triangle. And that's the same for all 4 of these triangles. If you wrote that on this one or another one, that's fine by me. So we've done 3 shapes. Now you have 2 left. So take a second, pause the video, do the next 2 by yourself, and then press play when you're ready to check. All right, so here's your final 2 3D solid figures, the measurements from their nets put on them. So today we learned that nets are actually the unfolded version of a figure. So nets are the unfolded version. The 3D solid is it all put together. We know that the nets are actually going to be really useful to us when we look for a surface area of figures, because surface area is like wrapping paper. It's like how much of the outside area in total is there on a 3D figure. It's a lot easier to do that whenever you have a net. And you also now have 4 definitions about 3-dimensional figures that are really going to help you moving forward. All right, guys, that's it. If you made it to the end of this video, please put in the comments your favorite Pop-Tart flavor. Mine is brown sugar cinnamon. Today I gave you an introduction to nets and 3D figures. So now you should be able to identify parts of those 3D figures and kind of unfold them to create those nets. So go ahead and turn back to the calendar, click any other assignments you have left for the day. Let me know if you have any questions. Bye.